Alright, so in this video, I'm going to be going over the basics and core rules of summation, and we're going to be solving question 1 from May June 25, paper 1-2 as we go. Okay, let's start with sigma notation. Sigma notation is a way to express the sum of a sequence of numbers in a compact way. The symbol sigma means sum of, and this expression next to sigma in terms of r gives the pattern that the terms you're adding will take in the sequence. And these terms are from your initial limit until your final limit. So for example, if you're finding the sum of r from 1 until 5, you're doing 1 plus 2 plus 3 plus 4 plus 5. Now I'm going to go over some basic rules and things to remember when you're solving. For our first case, you are adding 1 n number of times. So for example, if n equals 3, you are adding 1 plus 1 plus 1 3 times, which is just equals to 3. So this is n. The same logic applies here, except you're starting from 0. So you're adding 1 plus 1 plus 1 4 times. So this is n plus 1. When you're solving questions, you can split sums. So the sum of a plus b is the same as the sum of a plus the sum of b. So for example, if you have the sum of r plus r squared, that's the same as writing the sum of r plus the sum of r squared. You can take constants common outside of the sum. So the sum of k times a is equal to k times the sum of a. So if you have the sum of 2r, that's the same as writing 2 times the sum of r. However, the sum of ab is not the same as the sum of a times the sum of b. Please don't do this. For example, if you're taking the sum of r squared from 1 until 2, you get 1 squared plus 2 squared, which is 5. If you're doing the sum of r from 1 until 2 squared, whole squared, you get 1 plus 2 squared, which is 9. So these are not the same thing. And please don't write that. You might remember these from ADMAT. The sum of numbers from n equals 10 to n equals 20 means you take the sum of 20 terms minus the sum of 9 terms, because you need the 10th term to be included. And as we discussed here, the sum from n equals 0 to n equals 10 has 11 terms. There are a few different kinds of questions you're going to encounter, the first of these being formula-based questions. These formulas are given to you in MF19, so I wouldn't worry too much about memorizing them, and you're eventually going to do so much practice that you'll kind of remember them anyways. What you do have to remember is that you can only apply these formulas when r equals 1. This is the only case where you can apply these formulas. You might recognize the first formula from ADMAT. It's just the same as our sum formula, which I'm showing here. So our first term is 1, and our difference is 1. Okay, let's solve the first part. The first thing we have to do is expand this. When you're solving questions, make sure you factor common terms before simplifying. I'm going to get to that. So this is 9 times the sum of r squared is 21 times the sum of r. I'm apologizing right now for my handwriting and the horrible handwriting we're going to continue to witness. Now you substitute the formula values into this. you have to remember this is n, like we had gone over earlier, so this becomes 10n. Okay, 2, 3. Now we'll take 1 upon 2n common, so we get 1 upon 2n. We expand this, which gives us 2n squared plus 3n plus 1 minus 21n plus 1 plus 20. The only place where this is difficult is that people make mistakes while solving this out. I know I've made many mistakes in summation just because I made silly mistakes while expanding and taking common. So just be careful when you're doing this. I'm going to be solving more difficult questions in a later video. This is just so you guys understand the concept. Okay, let's move on to the second type of questions. There are a few different types of series, which you might remember from AdMath. Here, there's a telescoping series, which is where the general term is the difference of two things. And in this, you're going to apply the method of differences. For this, you need to remember partial fractions rules. I'm going to be uploading a separate video going over the partial fractions rules. But essentially, it's like the reverse process of LCM, where you combine two fractions, like you're breaking a fraction down into its parts. Method of differences is really satisfying. It only really gets difficult or tricky when you have the sum of two terms canceling the third. Okay, let's do this part of the question. So the first thing we're going to do is break this down because they've told us to do method of differences. So 1 upon 2 minus 3r, 5 minus 3r. You can either make you make simultaneous equations and you can either use elimination or substitution. So here I took LCM. I multiplied this by A and this by B. So they all have a common denominator. Now, to solve for A, I want to make this 0, so there's no B in this, right? So 2 minus 3r equals 0 when r equals 2 upon 3. So let's substitute r equals 2 upon 3 into this. We know that this will be 0, so this is going to be 5 minus 2, which means A is 1 upon 3, this A. We do the same thing to solve for B, where we make 5 minus 3r equal to 0, and r equals 5 upon 3. Let's substitute that in. And we got B as minus 1 upon 3. Okay, when you're doing method of differences, you need to take different values of r and try to recognize a pattern. So first, let's write this out. Let's take 1 upon 3 common, since it's common in both of these. So we'll take 1 upon 3 common, and we have 1 upon 2 minus 3r minus 1 upon 5 minus 3r. Now we substitute in different values of r and see if they're making a pattern. So when r equals 1, this is 1 upon 2 minus 3 minus 1 upon 5 minus 3. when r equals 2, we have 1 upon 2 minus 6. Wait, sorry, I'll just write these. So 1 upon 2 minus 3, 1 upon minus 1, minus 1 upon 2, and 1 upon minus 4, minus 1 upon 5 minus 6. You can already see that this term is the same as this term. So these will cancel out because when you write them out in the sum way, this minus this, since they're the same, is going to be equal to 0, which means it's just going to cancel out. Let's write out r equals 3 too. 1 upon 2 minus 9 minus 7 minus 1 upon 5 minus 9 minus 4. These are also the same, so they're also going to cancel. Now you can see a pattern where the term on the right is canceling with the one above it to the left. So these are going to cancel, these are going to cancel. And as we go further in the sequence, we can assume that this is also going to cancel. Now let's substitute our last two terms in. R equals n minus 1, 1 upon 2 minus 3, n minus 1, minus 1 upon 5 minus 3, n minus 1. When r equals n, you have 1 upon 2 minus 3n, minus 1 upon 5 minus 3n. Since each term is canceling with the one above and to the left of it, and we know there's a term over here, this is going to cancel. And this is also equal to 5 minus 3n. So this is also going to cancel, which means your sum is equal to the two terms left over, these two. So your sum is 1 upon 3, 1 upon 2 minus 3n, minus half, which you expand and write as 1 upon 3, 2 minus 3n, minus 1 upon 6. And this is your answer. Okay. The trickiest part of this chapter is probably limits and sum to infinity. Basically, there are two types of series that we learned in advanced and that we need to continue to know about. One of these is a convergent series. So when the terms approach 0, like the terms in a series get smaller and eventually become negligible, it'll reach a fixed sum because eventually the terms are going to be so small in the sequence that they just don't affect the sum anymore. Like if you have 50 and the thing you're adding on to 50 is like 0.00001, it's not going to affect it, right? Like its effect is negligible. So that's what we're going to be looking at. So there are a few different cases when n approaches infinity. So when n approaches infinity in 1 upon n, that means the denominator is getting infinitely large. And obviously, like the terms 1 upon 2, 1 upon 3, 1 upon 4, they are getting smaller. So when the denominator gets smaller, when the denominator gets bigger and approaches infinity, then 1 upon n is going to approach 0. Here we have a to the power n as n approaches infinity, as n becomes infinitely large. Here n is a fraction, like 1 upon 2 to the power n. As n gets bigger, this fraction is going to get smaller. Like if you have 1 upon 2 to the power 1, 1 upon 2 squared is 1 upon 4, 1 upon 8 is 1 upon 2 cubed. These are getting smaller, which means when this is between 0 and 1, when this is a fraction, is going to get infinitely smaller. So it's going to approach 0. However, when a is greater than 1, like you have 2 to the power 1, 2 squared, which is 4, 2 cubed, which is 3, it's going to get larger. So here, this term is going to approach infinity. It's going to keep getting infinitely larger. Here, you have 1 upon a to the power of n, where a is greater than 1. As n becomes larger, sorry, as n becomes larger, this is going to become larger because a is greater than 1, which means your entire expression is going to become smaller as the denominator gets bigger, which means as n approaches infinity, a to the power minus n approaches 0. For e, your natural log, it's just a number like 2.72. So if you're multiplying a number by like increasingly large numbers, it's going to get bigger. So e to the power n, as n approaches infinity, will approach infinity. And e to the power minus n, which is 1 upon e to the power n, en will approach infinity, which means this is going to get infinitely smaller. So e to the power minus n approaches 0. It's just a number like 2.72. So don't let this confuse you too much. Now let's do part C of this. Okay, we have our sum already. Just copy it. Okay, let's look at it this way. So the way I like to do this is I take n common from this. So let's take n common. You have 6 upon n minus 9. As n gets infinitely larger, 1 upon n is going to approach 0, right? Your final limit is infinity. So as n approaches infinity, your 1 upon n is going to approach 0, as we saw here, which means this entire expression is just going to become equals to 0. So this is all going to cancel out, which means the only thing left in your sum is 1 upon 6. So the value of this is just minus 1 upon 6. The other type of questions that you'll see is pattern questions, where you kind of see a pattern of numbers and you have to write out the sum. If you're finding the sum from 1 to n, that means you put the expression from 1 until n, as we've already discussed. If you're finding the sum of even numbers from 1 to n, like 2, 4, 6, 8, you'll do the sum from 1 until n of 2r, sorry. Because here when you substitute increasing values of r, you get 2, 4, 6, 8 until you get to 2n. When you're solving for the sum of odd numbers, one way to do it is you find the sum of all numbers minus the sum of even numbers. So this minus this. You could write this, but this is like the algebra is so bad and you're more likely to make mistakes. So I'd suggest you don't do it. This is usually the way to go. Okay. let's do these two patterns. So here you can see, let's do this one first. Here you can see you have odd numbers, 1 squared plus 3 squared plus 5 squared. And then your even numbers are all negative, right? Minus 2 squared, minus 4 squared, minus 6 squared. Now, to solve this, you can do odd number squared minus even number squared, which is the sum. I feel like I'm not explaining this that well, but I'm gonna upload a video solving more of these questions and hopefully it'll make more sense then. Or you can do the sum of all the numbers minus 2 times the sum of even numbers. Here it's the same thing, except you're doing your even numbers are positive. So you're doing even squared minus odd squared. So n plus 1 squared minus n squared is 2n plus 1. Okay, let me know if you guys have any questions. And considering this is my first video, I'll probably re-upload it sometime in the future. So drop any like advice or something you'd like to see me do differently. But for now, there's a WhatsApp channel and an Instagram linked in my bio that you guys should join, and you can send in questions for the video where I'm going to be solving summation questions. And you can message me if you need any help at all. I'm going to be making that video very soon, and I'll be uploading a partial fractions video soon as well. Um, Take care of your mental health. Further, it's difficult. Don't worry too much about not understanding something immediately. Just practice and you will be fine eventually. Don't worry. Okay, bye.